So now I'm going to write down Newton's second law, ma, which is all in the x direction, equals minus kx. A is the second derivative of position, for which I will write x double dot, mx double dot. One dot is the first derivative, that's the velocity. Two dots is the acceleration. Plus kx equals 0. I divide by m, and I get x double dot plus k over m times x equals 0. And this is arguably the most important equation in all of physics. It's a differential equation. Some of you may already have solved differential equations. The outcome of this, you will see, is very simple. X is, of course, changing in some way as a function of time. And when you have the correct solution for x as a function of time, and you substitute that back into that differential equation, that equation will have to be satisfied. What would a solution be to this differential equation? I'm going to make you see this oscillation first. I'm going to make you see x as a function of time, and I'm going to do that in the following way. I have here a spray paint can, which is suspended between two springs, and I can oscillate it vertically, which is your x direction, like that. So x changes with time. The time axis I will introduce by pulling on this string. When the spray paint is going to spray, I'm going to pull on that string, and if I can do that at a constant speed, then you get horizontally a time axis, and of course vertically you will get the position of x. So I want you to just see qualitatively what kind of a weird curve x as a function of time is, which then will have to satisfy that differential equation. All right, it's always a messy experiment because the paint is dripping, but I will try to get this spray paint going. There we go. Okay, now I'll pull. All right, could you give me a hand? Yeah, could you please? I will cut it here, and then you be very careful because it is messy. Or let's take it out this way. Okay, just walk back. Just walk, yeah, great. Yeah, hold up the top so that you can see it, fine. Okay. What does it remind you of? Sinusoids. It reminds me of a cosinusoid, by the way. Sinusoid or cosine, same thing. All right, well, let's try to substitute in that equation a sinusoid or a cosine solution. Whichever one you prefer, makes no difference. So I'm going to substitute in this equation, and this is my trial function, that x as a function of time is a constant a, I will get back to that in a minute, times cosine omega t plus phi.